Today we're on to the second part of this unit, structure of the atom. So our objectives here are to define an atom, list the properties of the subatomic particles, determine the number of protons, neutrons, and electrons found in elements from the periodic table. All right, let's get started. First, what is an atom? Atoms are the smallest particle of an element that retains the chemical properties of that element. So that retains chemical properties is super important. So as long as you can keep breaking it down and it still behaves the same way, it's not quite to an atom yet. Remember that atoms were named by Democritus and that the word means indivisible, which we know is not entirely true because we have nuclear fission now. What's an atom made up of? So remember our dead guys PowerPoint? Dalton, Thomson, Millikan, Rutherford, and Bohr discovered those subatomic particles. And all that subatomic particles mean, sub means smaller or below. So the things that are smaller than atoms. We've got protons, remember that they have a positive charge, neutrons with no charge, and electrons, which have a negative charge. All right, let's talk about the nucleus. In the very center, a tiny small part in the nucleus is called the nucleus. So that has protons and neutrons. It makes up the majority of the mass, so how heavy that atom is, and it's held together by what we call the strong nuclear force. Electrons, on the other hand, are found on the electron cloud or shells. That's what this portion right here is called. Makes up most of the volume. Remember, volume is similar to saying the size of the atom. So they're very spread out. They're not condensed the way that our nucleus is. Right, here's what we need to know about each of the particles. Electrons have a negative charge. In this picture down here, they are written as E, and a lot of times they'll be written with a negative sign. They're tiny, very light particles. So light, in fact, that we don't count them whenever we talk about the mass of an atom. And they're found in the electron cloud. Second, we have protons. Protons have a positive charge, and they are written as just a P in that picture. There's at least one in every single atom. There's not an atom in existence that does not have a proton. And they're much larger in size and mass than electrons. So this picture doesn't really show it, but protons are way bigger than electrons. And they're found in the nucleus. And our last subatomic particle is the neutron. It's neutral, meaning it does not have a charge. It's the same size as a proton, and it's also found in the nucleus. You'll find this down here. So what's going to be important is how many of these things we have. So let's just look at what we have right now, and we'll come back later. So we have 3 protons here. We have 4 neutrons, and we have 3 electrons. You may not know it yet, but that lets us identify this element. And let's talk about how. So whenever we measure an atom's size, we have 2 things that are important. Atomic numbers that are usually listed on the top of an element in the periodic table, and then we also have atomic masses that are listed on the bottom. So if you look at a periodic table, any periodic table, just Google one, atomic numbers on top, the symbol, which is just a shortened version of the name, in the middle, the full name, and then the atomic masses on bottom. This atomic number at the very top tells us the number of protons. So in this particular atom, any atom of lithium, there will be 3 protons. And the atomic mass that's here on the bottom is the number of protons plus neutrons. Now, lithium is 6.94 for its atomic mass. This is an average, which has to do with isotopes, which we'll talk about later. But if we know that the mass of lithium, let's round it to the nearest whole number, is 7. And we also know from the atomic number that there are 3 protons. Then we know that 3 plus some number equals the mass. So the number of neutrons in this particular atom would be 4. Interesting on the previous page that we had 3 protons, 4 neutrons, and 3 electrons. So what we saw here in this Bohr model was a lithium atom. Okay, let's talk about the electrons. If an atom is electrically neutral, now I want you to pay attention to this because we won't always have electrically neutral atoms, and all that means is that there is no charge. What I mean by that, whenever you have a charged atom, you'll have it written as Li plus or O2 minus. If you don't see a plus sign or a minus sign above it, then it's neutral. If it's electrically neutral, then protons equal electrons. So for this electrically neutral lithium we had back here, it had 3 protons, which means that it also had 3 electrons. I'm going to call that E negative whenever I'm writing these PowerPoints. Next, let's talk about isotopes, where we get that weird number from. So isotopes are atoms of the exact same element that have different masses. So they have the same number of protons always and electrons, but they differ in the number of neutrons. Super important for you to remember. Burn this into your brain. All atoms of the same element have the same number of protons. Every lithium atom ever has 3 protons. But they can differ in the number of neutrons. Those are those neutral particles in the nucleus. Several different ways to write the isotope that you have. You have this isotope notation where you have the element symbol written big, then the mass number written over the atomic number, or you can just write the element name dash the mass number. So let's talk about 2 of those just so we can get used to seeing this. 2 very common isotopes are carbon-12 and carbon-14. Now, if I was trying to figure out how many protons and neutrons there are in carbon-12 and carbon-14, first I would want to look at a periodic table. Because on the periodic table, I'll find that atomic number for carbon, which tells me that every carbon atom has 6 protons. Always, always. And then I can do a little bit of math to figure out how many neutrons. So if I have protons plus neutrons equals the mass, then I have 6 plus something equals 12. So to figure that out, I would just move it around and see that 6 plus 6 would equal 12. So carbon-12 must have 6 neutrons. I'll do the same thing for carbon-14, because you can probably tell the numbers aren't going to add up quite the same. P plus N equals 14 this time, so 6 plus N equals 14. So the number of neutrons in this one is 8, because 6 plus 8 equals 14. So, just pointing out one more time that protons are both 6, neutrons are different, and that makes this an isotope. That is all that's different about an isotope. Alright, that was it for today's lesson. You did great. I can't wait to see you again. Bye, chemists!